Okay, waiting for people to join. I will wait for a minute or two so everyone joins and we can start. Okay, it seems that majority of people have joined. There are about 35 attendees at the moment, and it's 6 o'clock here in the UK, so we can we can start. So good evening, everyone. If you are actually joining from UK, good day. If you are with us from any other part of the world. My name is Human Takhtijan, and I'm the current ICorr Aberdeen Committee Branch Chair. Welcome to our February technical program, which is a presentation by Leo Richards from Intertech. So before I start, just a quick note that the webinar, as usual, we are recording the webinar, and this will be available on YouTube, our YouTube channel, for your future reference, or if you want to forward it to anyone else who is interested or couldn't join our meeting today. And please note that we asked questions from the audience at the end of the presentation. Dr. Oli, who is our Vice Chair, ICorr Aberdeen Vice Chair, he's going through the questions. So please make sure ask your questions at the Q&A section, not in the chat section, which could be lost. And Dr. Oli will select the questions. And please limit the questions to 1 or 2 per person, so we can go through all the questions. So let me share a very short introduction to ICorr Aberdeen event and program, and then I will hand over to Leo to start the presentation. Okay, so as you have seen probably from the flyer or the post on the LinkedIn or the emails you have received, today presentation is by Leo Richard from Intertech's Production and Integrity Assurance Group. And the topic is the implementation of Plan, Do, Check, Act, review of an onshore oil and gas operators corrosion management policy and actions. He's joining us tonight on the panel with his colleague, Andy Duncan, who is the lead consultant, also from Intertech. He will be supporting Leo during the question and answer session. So just a quick one again. First of all, I would like to thank you all, our branch sponsors, who have kindly sponsored us regularly, and this has enabled us to keep all our monthly meetings happening without any interruption or gaps. For the last several years, we had all of these branch sponsors supporting us COVID time and before the COVID. So really appreciate that. Also thank you for all Aberdeen branch committee members supporting us for event organization and other activities throughout the year. And just a note about the previous presentation and slides. You can find them on our website, on ICorr Aberdeen website. You can go back to a few years back with all the presentations, slides and events, photos and galleries and stuff like that. Also on the Icor main website, you can find the news and the updates and the previous presentations. As I mentioned, the recordings are available on YouTube. You can go back and watch them. And the program for the rest of the year, we still have 3 more technical presentations. March from University of Manchester. Next event will be by Dr. Robert Lindsay. Is still a virtual event, Zoom event, same as tonight. The next 2 events will be in person in Aberdeen by Preserve, which is a joint meeting with AMPP, NACE, previously known as NACE. And the May event is I call it technical event plus AGM, which there will be a presentation by PIM. Also, we are at the moment preparing for annual corrosion forum, which we have with every August. Dr. Oli, he's preparing that. The theme of this coming annual corrosion forum is energy transition and net zero target. So it is very interesting, a kind of different theme from all previous themes, and it's something that we thought that is actually taking a lot of interest at the moment. Dr. Oli is sending at the moment announcements for speakers and sponsors for the event as well. So if you are interested or your company is interested and in the relevant topic, please contact us or Dr. Oli to start organizing for this upcoming events. Just one last note about what's happening in a young engineer program, Icor Young Engineer Program. We just launched the program the last week of January with the first session, the introduction session, and the first lecture. We had all the 24 candidates presented at this event, and this is going to continue until November with their case studies and the competition in November. If you are interested in to participate in the similar program in future, please make sure you check our website or our announcements for the next session, which will be 2024, and most probably will be based in London, hosted by London branch. Yeah, so that's me with an introduction with ICorr Aberdeen activities. So I will just pass it to Leo to share his screen. But before that, just an introduction to our speaker today, and Andy, who is supporting him during the question and answer session. So Leo is a principal engineer in the production chemistry department within Intertek's production and integrity assurance group. He has worked in industry for over 13 years, working on a wide variety of oil and gas projects, including microbial soldering investigations, and mitigation laboratory studies, system assessment for carbon capture and sequestration projects, chemical treatment and corrosion studies for large seawater injection systems, and operational and corrosion management systems reviews. Leo gained his bachelor degree in chemistry from the University of Sheffield in 2006. And Andy Duncan, who is a lead consultant with Intertech Production and Integrity Assurance, is a chartered engineer and a fellow of the Institute of Corrosion with 40 years experience in oil and gas, refining and petrochemical industries across some 20 countries. Prior to joining Intertech P&IA 6 years ago, he worked for BP, Associated Octal, Capsis, and the UK Health and Safety Executive, where he led the external corrosion project and the key program for KP4 on aging and life extension of offshore oil and gas production facilities. Andy is a member of the IOM3 Energy Transition Group, the IOM3 Corrosion Group, and also the Energy Institute Corrosion Management Committee. Andy is active in mentoring engineers and scientists of the future inside and outside of Intertech. So with that, I invite Leo to start his presentation. Let me stop sharing. And also we have a poll that I will run it now for 30 seconds or a little bit more to have some feedback on the topic today before Leo starts presenting. So I will launch it now. So the question is, out of the 4 stages of Plan, Do, Check, Act, which, if any, do you think or feel is the hardest to implement? We have 30 answers received out of 45 attendees. Okay, 40, and probably that's all, 41. So I end the poll to see the results and sharing the results. So 32% plan, 27% do, 17% check, and 24% act. I will let Leo to comment on that and start his presentation. Thank you.
Thank you, Human. So first of all, thank you very much to Icor for giving us this opportunity to present tonight. Yeah, so the reason we put that question forward as the poll question was when we were looking at this, implementing it, doing the study, we found there was a common theme, which we'll come to, but when we were discussing it, we were, within the office, we were saying that looking at the way people work and the way they tend to think about things is the plan and do part, which seems to be the sort of the exciting, you're getting on and implementing something new. So that a lot of people are able to start those and get them underway, but it's actually the ability to stop and review and reassess, and where the check and act part comes in, which is the bit which a lot of people, which we've felt that people from a technical background may well struggle with. So that brings me to the title presentation. So implementation of Plan, Do, Check, Act, Review of an onshore oil and gas operator's corrosion management policy in action. Now, typically, for myself, I'm a very technical based person. A lot of my day-to-day work is very technically based, and so when this project came in and I started to discuss with Andy about the implementation of it, I was a bit sort of I was intrigued to see how it would actually come together and what I could actually contribute to it. But it very quickly became clear that a lot of the methodologies and outcomes that when implementing this can actually be applied in all sorts of scenarios, from project delivery to from experimental projects through to desktop projects, and it was quite interesting to actually see. And I think there's a lot of, with the different stages, there's a lot of ways that they can implement or help people or help deliver where projects where certain aspects aren't people's strengths, but by formulating this plan at the beginning, it can really help push through projects completely. So first of all, some study background and methodology. So in SET PNIA, we were asked to supply third-party expertise for a study to upgrade the corrosion monitoring and mitigation activities for an onshore oil and gas field. So we were asked to study and assess and identify the current corrosion management techniques and its effectiveness within the field, identify gaps within the management technique and within the corrosion management technique, and also provide corrosion management proposals and to fill in the gaps to ensure that the corrosion management policy was of world-class and result in excellent assets integrity performance. So the study was broken into two main sections. First was a document review. So this was both desktop based in the UK, but also within the client's offices as well. I'm sure there's a lot of you will know when looking at requesting data, well, you can initially you start to get a large amount of data will come through. And we typically see this in projects, but getting the last few bits of data due to anything from sort of just different nomenclature, people refer to things in different ways, actually being in the office and being able to do the paper following and get the information can really help push forward the study. And there was also the site element to it. So we attended various parts of the field's production system this was a gas, well, they produce all sorts of fluids. So gas, there was gas condensate production as well as black oil from this field. So a variety of different stations, gas stations, degassing stations, gas recycling plants, produce water injection stations, gas distribution, as well as stripping plants. So we were looking at all of these different types of process and how the corrosion management mitigation documents apply to each of them. Now, the wording of the proposal and the report said that the purpose of the site visit was to gain an understanding of the integrity management activities, the corrosion control monitoring and mitigation programs, and also look at repairs, as often repairs, especially so they can be implemented as temporary repairs, and then 3-4 years later find they're still there but listed under temporary repairs and not moved on to fully permanent repairs. And also while on site, so determine the current and projected process conditions. So that's to help determine whether the corrosion management document as is would be suitable as the life of the field progresses and the composition of the fluids, etc., changes. And make sure that the system was able to handle any future operational conditions. Also, and part of that, we need to look at the fluid compositional data, not actually performing the samples, but to see what sort of measurements and monitoring they were doing, the operator was doing on that side of things. Looking at the chemicals that were being dosed to address these the various corrosion issues that they had. And also looking at the materials of construction, so making sure that what they were saying that they were using was was actually what was there, and in places of where high alloys are used, that's actually what was in place, and that they're using materials of construction as a method of corrosion mitigation. Now that was on paper what the purpose of the site visit was for, but really the critical thing that we took from the site visit was to actually talk to the operators and personnel at site. The amount of information we were looking through ultimately didn't matter if you got to site and you found out that actually they'd never used that document you reviewed, or or it's a different version, or that part of the process no longer exists. So actually getting to site, talking with the people to determine what was going on. On paper, everything could have looked perfect, but actually when you get there, you can find out it was very different to what your understanding was before you got there. So how do we go about the study? So the basis of the study was the implementation of the guidance within the HSG 65. So HSG 65 is a HSE document which could be used to assess the effectiveness of any organisation which relies on systems, procedures and methodologies, and organisations that are required to operate in a safe and effective manner. Now, this tied in quite nicely with a review of the corrosion mitigation aspects, as the Energy Institute's guidance for corrosion management in oil and gas production and processing follows this plan, do, check methodology, which is highlighted in HSG 65. And so we looked at applying that across the various monitoring and mitigation processes that the operator did. So here's an overview of the plan, do, check, act system. So starting with the planning, so that the input into that is the first of all policies. So what documentation, what guidelines are there within the organisation? So this is quite a high level. So the health and safety policy, company mission statements, and other corporate policies. And then also alongside that, the actual planning of the action or system that you're reviewing. So looking at what's going to be physically going on, who needs to be there. What's going to be done. So who, what, why, when, how. So planning what teams needed there, when it's going to be done, what's going to actually go. And also why looking at does it have to be done, is it critical that it's done at that point, because any of these, or a lot of these actions have a risk associated with them, so making sure that it's justified to do that action is key. So once the plan's in place, you can go to actually implementing your plan, the do part of it. So this is everything from organising the team, making sure that there's nothing that within the action could be hazardous, making sure the right people are there with the right equipment, etc., and getting the information and getting the task done as safely as possible. Now, once the task is over with, then you can look at checking to review what was going on. So you can look at measuring the actual performance. So this might be something along the lines of looking at the manpower requirements. Was it planned to be 2 men for 1 day and ended up being 3 men for 2 days? Was it budgetary? Was it lead time? Those kind of things which help you review what was going on. And then also, was there anything untoward that happened? Were there any incidents, accidents, etc.? And why did they occur? Any incidents, accidents, and what happened, and what was the situation around that? Once you've got those key figures, the performance, and the incidents, then you can look at acting on them. So you can look at the lessons learned, and you can review the performance. You can see why things took longer, or why, and possibly what accidents or what incidents occurred, and what you can do to mitigate it. So on the act part of it, it's a case of building up the lessons learned and understanding what happened from the do stage onwards. And critically and absolutely vitally, that then needs to feed in, and there needs to be a change to the plan. The plan, the whole point of this is that the plan, which says what you're going to do, is optimized each time you go around the circle. So ultimately, it's a constant feedback loop, and things should be getting. There'll be less and less to do each time, but but it is important that that cycle's complete, and that even if there is no changes, that's acknowledged and it's gone through. So applying this to the corrosion mitigation and monitoring activities done at the operator's field. So we followed the same sort of circular review. So initially a review of the corrosion monitoring and mitigation documents, and that intertwined with interview with corrosion engineers, lab personnel, people actually doing the work. Then we looked at the reporting practices and pathways. So what happens when they've got the information, where does that go? And then review of the higher document, the corrosion management policy, to see what the general ethos is behind what they're trying to achieve and how they're trying to do it. So within this, this wasn't hard and fast, but that we would to fit this in within the Plan, Do, Check Act, we assigned the overlap between the review. So the do part of it was what happens when they take the monitoring mitigation plan and actually put it in the field, and that's you get that information from review of the documents as well as interview with the people who actually go do it. The check part was following discussion with the people and seeing what the results were gained and how that was inputted. The Act was based upon once the information was put into the system, how does that feed back into the corrosion management policy? And then the corrosion management policy fits in with the monitoring and mitigation documents for a plan of how they're addressing the various corrosion issues on site. And so once we've gathered all that information, we looked at scoring on a simple traffic light based system, red, amber, green, of the individual parts which went into the Plan, Do, Check Act for the various processes. So red was, in our opinion, didn't meet international accepted norms for integrity management, and a lot of improvement was required. Amber was that fundamentally there was a basis there, but there was still quite a bit of work required to improve the system to a point where it met international norms or excellence. And green was everything was good, the system worked well, and we said that was as good as you could hope, and that the system would sort of maintain itself at that level. So within the study itself, there were numerous topics that were covered. So on the corrosion monitoring side, we looked at the intrusive corrosion monitoring, deposit analysis, scaling tendency, which while some might not be directly associated with corrosion, but there's the potential of under deposit corrosion, so that was included. Microbial assessment is the potential for MIC within the system, and what's been and how are they assessing that. And as so we looked at all sorts of numbers of different plants. So there were lots of systems which had cooling water, glycol systems as well. So we looked at the quality of both cooling water and glycol. A lot of the systems were coated. A lot of the systems operated at elevated or depressed temperatures, so there was a lot of the system was insulated. So looking at corrosion under insulation and what was doing to make sure that that wasn't an issue. Also look at the lab procedures, the documents and reporting to determine whether the samples analysis they're doing is supplying the quality of information they need to make the decisions for the mitigation. When it came to the mitigation, we assessed the policy for the continuous corrosion inhibitor injection as well as batch corrosion inhibitor injection. Looked at scale inhibitor and biocide shock or batch dosing. We looked at a lot of the impressed current system, so the impressed current cathodic protection for, as well as the sacrificial anodes for road crossings and tank internals, the chemical treatment for cooling waters, the external and internal coating specifications for the equipment and structures, and also what's done regards permanent and temporary repairs. So these are all the topics which basically feed the technical basis of the corrosion management policy. So all of these are sort of sit within the plan part, and then all the information, and it all feeds back into the overall overarching corrosion management policy. So that's where the ACT part of the circle can feed back in. So overall, the study outcomes. So as I say, when we looked at breaking down the outcomes of the study, so we started at this very high level and worked our way down into the individual processes and procedures that the operator was utilising. So overall, so we had the traffic light system, so green, amber. So green meets the standard, amber needs improvement, and red is significant improvement required. So starting off with the overall, the planning aspect of a lot of the procedures and policies was good. They did. There was some technical and documentational improvements that were required, but overall, it was a good standard. The do parts of the implementation, there was overall all the staff were professional and delivered in a timely manner. However, a lot of the actions were taken on calendar-based schedules. There was no risk associated with what they were doing. So inspections, etc., weren't done on a risk-based schedule. Now, going from there, going on to the check and act. Now, both of these overall were needed significant improvement. So once they planned what they were doing, they went out and did it. But after that, the information or the review stopped there. The information was uploaded to spreadsheets, uploaded to databases, and there was no further follow-on from that. So as an overall summary for this is the outcome of the study. But But as we go on, I'll show how we went through the individual, some of the individual topics in more detail. So how did we come to the conclusion? So on the planning, so the planning part the topic was rated as green. So there was policies and procedures, but they needed reviewing and updating. And the approach to it was endeavoured to be fulfilled in a professional manner, so all the people were well trained and able to fulfil what they were doing accordingly. As I mentioned, on the do part, overall there was no risk based planning to what was done. It was either done opportunistically or done on a calendar-based method. However, the organisation and implementation, as I said, the people were professional and knew what they were doing, so that scored. That was rated as green. On the check and act, as I said, both of these got were reviewed to be read. There significant improvement required. So there was no formal system in place to measure the performance of its monitoring mitigation. There was very little in regards trending and assessing the impact of mitigation schemes, etc. When it came to reviewing deficiencies, it was only the major incidences that were investigated. There were numerous small incidences that ultimately accumulated and resulted in larger, more serious problems. However, at the time they were ignored and just accepted as part of the day-to-day operations, and so that was highlighted as a major flaw in how they were reviewing, how they were checking on the data and reviewing it. And also, if the act stage was also read, but obviously if you're not checking what you're doing and the information that's coming through properly, it's very difficult to act on it properly. So there needs to be a formal system in place to review and the mitigation, review the monitoring and mitigation program performance, and increase the importance played on lower level incidences, as they do build up to ultimately generate significant instances eventually. So to say, with regards the corrosion monitoring, corrosion mitigation, there were numerous topics which we looked at addressing, but just for the next few slides, I'll just focus on two of the corrosion monitoring and two of the corrosion mitigation. So look at the intrusive corrosion monitoring, ER probes, corrosion coupons, etc., and the external and internal coating assessment. And then for the mitigation, we'll look at the differences between the application and of continuous corrosion inhibitor versus the batch corrosion inhibitor that was deployed at the site. So for corrosion monitoring, so again, the planning and the doing, in this case, the check part of the program was there. The planning part was overall well done. There was well-written standards, but due for review, some minor technical errors. The planning for the retrievals and probe readings were well planned. However, a few minor things. There was no tag numbers on the intrusive corrosion monitoring points in the field, and there was a lot of data knocking about on various systems. There was no centralized management software. And again, the risk profiling, again, I think in every topic that we reviewed had the issue of it wasn't based on a risk, it was just based on an opportunity or a calendar base, so that there's potential to optimize the retrievals. But overall, the organization was very effective, and the implementation of the plan was very effective. But there was a need for a central support function to make sure that the team could keep delivering that high level of quality. The measuring of the performance, there was without a centralized system, there was no way of correlating what you're seeing on the reported corrosion rates with things like corrosion inhibitor injection, corrosion inhibitor residuals, production rates, those kind of things. There was no way to tie it all in together. So yes, so there was no ability to trend and to identify to forecast future risks. We suggested at this point that using a similar system that we were implementing in the report to highlight to upper management to implement a traffic light system to show that where things are within the designed KPI or whether they stray beyond the KPI, so that things can be easily highlighted and action taken accordingly. And again, the act part of it, it's very difficult to act when the checking wasn't being done. So there was no correlation why corrosion rates were higher or lower than planned, and the ability to then feed that in and plan and act accordingly. Now, this is one of the key takeaways that we were a bit taken aback from, was the fact that there was primarily one corrosion technician who was responsible for the maintenance and operation of over 1,500 spreadsheets. So this poor chap who, how they ever let him go on holiday, I don't know, but because everything was kept in his head and on his computer, so that was really highlighted as an issue that could both streamline what they were doing and also allow for them to get much better idea of what was going on within the field. So yeah, so just so the recommendations. Trending recommendations was recommended across the field. To plan the retrievals and readings based on the corrosion risk, link the retrievals to corrosion injection rates, performance, NDT data, etc. One of the things we saw from a practical point of view was the corrosion coupon fittings were just a dust cap rather than cap fitted with the bleed valve and pressure gauge to indicate if there was any issue behind the cap. Review of the standard, although it was overall quite good. The retrieval procedure should be followed at all times. By that, discussion with the people in the field. When we talk about the coupon retrieval, they told us, we asked, how do you pressurize up the device? And we got the correct answer. However, we knew that wasn't always the truth all the time. We suspect that they sometimes pressurized up off the line rather than using the external pump as they should have done. One of the other key factors that we identified is in order to help delegate and spread some of the responsibilities, that the creation of RACI charts, so responsible, accountable, consultant, informed, would greatly help the corrosion team as a whole. So just for those who don't know about RACI charts, so the RACI charts, so responsible is who actually does the action, who collects the corrosion measurements, who conducts the analysis, who updates, etc. Accountable is the person whose job it is to make sure that the work is done. Consulted are the people who can help input into making sure that the work's done, technical specialists, consultants, etc. And then the informed person is the person who has overview and checks that the task is done. So an example of this is the corrosion coupon retrieval. So who's responsible for it? The the coupon retrieval team. And that's been driven by the accountable person, who's the corrosion engineer. Now, between them, they can consult with corrosion consultants and corrosion monitoring equipment suppliers, maintenance departments, etc. And overall, the integrity supervisor is the one who makes sure that it's going ahead. Now, obviously, the names and the terms used will vary from organisation to organisation, but this just gives an idea. And it also shows how you can use this to go from one task to the next. So following the coupon retrieval, you'd be looking at coupon examination. So they've gone to the effort, they've got the coupon out. Now, who's responsible with what happens next? So responsible is to make sure the weight loss analysis is done. The corrosion laboratory technician is assigned that task. The lab supervisor is the one who is the person who needs to make sure the task is complete. They again can consult with the corrosion engineers, equipment suppliers, maintenance, etc., whoever needs to. And ultimately, this is information for the corrosion engineer to input into his system. So he's the one who needs to be kept informed of what's going on. So the application of RACI charts allows the right people to be doing the right job, and allows people to identify when they're able just to get on with the job, rather than the methodology which was employed by the operator, which was very kind of fluid and things weren't definitively assigned. So we thought that this would be a good thing for them to take forward and push forward and help streamline how the processes were delivered. So moving on to the external and internal coating. So here the planning section, achieved amber. There were specifications, but they were overdue, and it referred to outdated samples. There was very little in the way of technical detail and no detail on inspection methods and criteria and acceptance levels. As I mentioned before, across the board, risk profiling was read. It was either time or opportunistically based. But again, the people doing the work, when asked, were competent, professional, and effective. But again, once the information was gained, there was very little done with it. There was no evidence that it was fed back into the procedure. There was no evidence of formal investigations. And the only record really was of repairs. But having said that, the coatings that were observed appeared to be in good condition. But that's, you know, a small, just tiny percentage of the overall system. So there needs to be something formalised and implemented. And again, no, if you're not checking, then you can't act on that and can't complete the feedback loop. So the recommendations were basically a whole-scale refurbishment or revision of what they were doing. So update, revise, and expand the inspection documents. Separate out the requirements when it comes to new build of plant versus maintenance of existing. They're both addressed by the same standard. There was pipe wrapping at various places throughout the system. A lot of soil there, interfaces were where the wrapping needed addressing, and obviously if they're following a procedure didn't actually address this. Simple references to international standards. There were the various standards of various ages referred to. The inspection should be based upon actual predict or perceived degradation methods, so corrosion under pipe supports, fretting under pipe supports, so things that you can, which you may walk past on a daily basis, but actually you take a step back and realise, okay, that could be an issue. We do need to check on it, be it once a month, once a year. But as long as it's identified. Again, with all of the data that was gathered, was the ability to trend it and identify the likelihood of non-conformance and optimise inspection schedules, because any data that was gathered wasn't used to help with that. So there are a lot of people potentially doing a lot of work that didn't need to be done. And further from that, the creation of RACI charts, again, for all of these systems would really help to streamline things. So on the corrosion mitigation side, so now we looked at so they're dosing corrosion inhibitor in two different ways: continuously and as a batch dose treatment. So on the planning side, there was very little. The planning side overall was rated as red. There was a lot of reliance on what the vendors were telling them to do. There was no independent confirmation of the corrosion inhibitor performance. And that also tied in with field trials and the testing of corrosion inhibitor under pipeline conditions. So basically the reason the corrosion inhibitor was dosed at the concentration and the location was purely based upon that's where the vendor said the chemical should go in. There was also cases where there were oil-soluble corrosion inhibitors being injected into gas lines with low water cuts. So there was no, as far as we can understand, no credible basis of why that particular chemical should be used in that situation. So there was very much a lead from the chemical company that they needed to challenge and start to understand why they were doing what they were doing and where. On the do part, again, no risk profiling. They were putting it into all pipelines because they were under the impression they should. So, for example, pipelines with dew points of -27 were being dosed as the same, almost in the same manner as wet gas pipelines. So there was very they need to understand what they were doing and why. There were overall where the chemical was being put in, the equipment was satisfactory, however, some omissions and also some records which appeared to be slightly, well, say, recently updated. But overall, where the chemical was being applied, it was the equipment was in good condition. There was also situations where pipelines identified as should have corrosion inhibitor injected were undergoing long periods without or low rates. So, and this tied in with the dose rates didn't actually match what the vendors said. So the only bit of advice that they had regards to the dosing concentration wasn't actually being achieved. So while the corrosion rates was extensively monitored, so by Corrosion Coupon and ER Pro, etc., there was no tie back to the actual corrosion inhibitor injection rates. So there was no identification of whether they were overdosing, underdosing, or what the actual benefit from the chemical going in was. And so on the Act point of view, there was no procedure for reviewing the performance. There was no tying everything together. So there was no lessons learned, nothing being taken forward on the back of it. Now, having said all of that, so with the recommendations, the recommendation, we strongly recommended that that there be a more stringent understanding of why, where, and how they were dosing the chemicals. So get the vendor to fully explain the basis for dosing the chemicals, where and how they were. Also determine whether, because a lot of the chemicals that were being dosed were still the same chemicals that were selected 5-10 years before. So potentially the technology has moved on, and also the systems moved on. Are those chemicals still relevant for the fluids through that they were aiming to treat? There was no independent testing of the dosing rates, where although there was a standard, internal standard that the operator had, it was not actually used. It was purely based on the what the vendors were recommending. And again, what the vendors were recommending wasn't necessarily based on the actual pipeline conditions. As discussed before, the corrosion inhibitor injection needs to be tied in with the observed corrosion rates and adjusted accordingly, and also adjusted accordingly based on the production. If wells are being turned on and off and the flow rates are changing dramatically, then that needs to be taken into account in the injection rate. With from the lab side of things, samples were collected, and the methodology used wasn't necessarily applicable to the actual type of corrosion inhibitor within the package. So whether the results they were getting were actually applicable, when we did the review, we believed that they wouldn't be getting a sensible result, and so we recommended that they change the testing to match the correct active ingredient within the dosed chemical. And again, with regards to review, match the corrosion inhibitor injection with available inspection data, so NDT and inline inspection, and assign again RACI charts to optimize optimize the inhibitor usage. So having said all that for continuous, the batch corrosion inhibitor was a very different set of results. Overall, very good. There was very little in way of recommendations. Now this actually came about because this was one of the few areas that the corrosion team had actually had time to review, and so they had a new procedure in place and a new contract with a chemical vendor to make sure that the chemical was being dosed in the correct way at the correct place, and the correct methodology was followed. So the planning was well done. The actual application. So the application was based on the historic corrosion rates and debris, and the application was adjusted accordingly. Again, checking so once the corrosion monitoring data was retrieved, and inline inspection data that was also correlated with the corrosion inhibitor residuals and the methodology and the review of the corrosion inhibitor dosing at the during the do section of the batch inhibitor application. And in fact, this highlighted one area that on the back of what they'd done in this improved procedure, there was no significant corrosion issues within these pipelines, and no issues regarding the actual application of the chemicals. So there was no requirement to review accidents and incidents. And again, on the ACT part of it, there was the closing of the loop, the feedback into the plan. So concentrations, dosing rates, etc., were changed accordingly. So overall, this was I suppose the diamond in the rough of the projects that showed that, given the time and the ability and the dedicated manpower to start acting on to start implementing these things, they're more than able to actually deliver very good mitigation and monitoring mitigation. It's just a case of getting things lined up. So the only recommendation was the confirmation, independent confirmation on the batched corrosion inhibitor performance and concentration, but from what they'd seen with regards to actual in-field inspection, that was less of a worry because there were no significant corrosion issues. So in summary, on the corrosion monitoring, there's an obvious theme there where the planning and doing were they were adequate but needed improvement. But once you got to the check and the ACT parts, there was basically nothing implemented there to close the loop. The checking based on the data wasn't conducted, and therefore there was very little to act on. Now, there was obvious a place for improvement if they started to focus on the check and act and close the feedback loop. With regards to the mitigation, now that was there were a few key areas where they had very little experience and very little knowledge, and that shone through. So this scale inhibition wasn't. This was so scale was dealt with by the corrosion department, who it wasn't an area they were particularly technically strong in, and so that part was basically it was ignored and just followed vendor recommended practices. Again, same with the biocide shock dosing. There was a lack of understanding in regards to what was required there, and therefore, from the very early stages of planning and doing, there was a lot of improvement across the board. And finally, temporary defined life repairs. There was very little information on that, and as I said at the start, some temporary repairs were about 4 years past being temporary. So there was a lot of work and required there to try and get that system up to speed. So it's a bit quite a bit more varied on the mitigation, but which primarily probably comes down to the requirement for more people and a better system to correlate the information, because that's key. If they don't know what's going in and where it's going in and how that's affecting the system, then they're not going to be able to optimize this. So that was a big take-home finding from the study, that they need to really, when they generate the data, to basically use it. So this is an additional slide which we've added just discussion with the human. So where this study was conducted in back in 2019, before everything went became very, very different. So obviously the world changed a lot over the last 2 years, changed the working patterns, project delivery, moved towards remote and automated inspection and monitoring, reduced personnel on board and offshore platforms, etc. Try to minimize the interaction. So what does that mean regards the application of Plan, Do, Check, Act and within a corrosion monitoring and mitigation. From the way, if that's the way that things start to go forward, then the planning stage of these becomes even more important, because if the planning's wrong and the wrong thing is the wrong thing is planned for, then the automation is basically pointless, because with any automated system, there's garbage in, garbage out. If you're monitoring corrosion rates by in-place sensors, various monitoring equipment, probes, etc., and the plan at the very start, the sensors are in the are not in the correct place. So so if they're not focusing on where you're most likely to have corrosion, where, or even slightly out of place, or that will potentially that the information they gather doesn't tell you anything about what's going on. Having said that, if the planning stage is done properly, the automation will make the do stage a lot quicker and easier. And in theory, the check and act part as well, because you'll be able to look at the information as it comes through and be able to review. However, I also think that there's potential for complacency with the check and act. Automated systems are not automatic. Sensors will need calibrating, locations confirmed. The system confirms is the same. Is it still applicable with what you have, with what you're monitoring where? So it's got a lot of potential power, but it's very easy to slip into complacency, I think, when it comes to automation and automation with these systems. So the data really does need to be checked, reviewed, and scrutinized to make sure that what you're seeing is actually correct and applicable. And also the act stage will have a double impact. So you need to act on what the data has shown. Is it shown high corrosion rates, low corrosion rates, but also act on how the data was gathered. Has the sense check been applied to the data, and if the data needs to be gathered in a new, improved way, that needs to be part of the act actions to feed back into the cycle. So there's potentially a lot of interesting and potentially powerful information that will be gained from automation, but it's a double-edged sword. So it's but can be managed with the application of the Plan, Do, Check, Act methodology from the start. So on that note, thank you for your attendance. If anyone has any questions, myself and Andy will be more than happy to answer.
Thank you very much for that, Leo. That was an excellent presentation, lots of detail. So, yep, as Leo said, if anyone's got any questions, if you could put them up, and we'll start going through them. So, first one here is relating to the initial criteria that you put up. What was the benchmark / criteria to classify the Plan, Do, Check, Act as meeting or needing improvements?
So they're based on our own internal expertise and also international knowledge. So for example, the Energy Institute documents, which give a lot of information on things like corrosion in oil and gas production systems. So we use those as the basis of that. Those are the things, that's where you're trying to achieve, and then assess how they were trying to get to that point, if they were getting to that point. So we're using sort of a lot of international standards, also sort of industry standards. Yeah, so that was really the basis. I don't know if Andy, if you have anything to add to that.
Yes, so you'll have noticed that for what we looked at was a wide variety of subjects. Each subject has its own area for KPIs or integrity operating windows, if you like. So the guidance for the benchmarking for cathodic protection is completely different to the benchmarking for continuous corrosion inhibitor injection. However, for each of the areas, there is international guidance that you can use to refer to for benchmarking. So first thing is to benchmark against the international guidance, the international standards. And the second thing is to use the company's corporate experience to match it against experience of what other world-class leading companies are doing.
Excellent. Thank you very much for that clarification, Andy. Okay, next question, which is somewhat very specific, and we may need to clarify outward of this, but we'll ask it here. So, what are the guidelines for internal coating integrity assessment for an in-service pipeline which cannot be subject to ILI?
I'll take that, Leah. They are, well, my view is there aren't any guidelines. And secondly, on a personal point, I'm not a great fan of internal linings because they have a habit of coming off. There are areas where internal linings of coatings, and by internal linings, I'm generally referring to the likes of fusion bonded epoxy, two-pack epoxies generally, which are quite commonly applied internal lines. They have a long history of failure, with some exceptions, of course, but certainly in a number of areas that I've seen FBE applied, very often you'll find the FBE plugging up your valves and your pumps and your separators in due course.
Oh, thank you very much for that. Okay, next question we have. To what extent do you think the Act can be planned, e.g. what to do if the corrosion rate is high, or is each too different to act?
Right, so let's take the example of corrosion inhibitors for that. And you can apply this approach to any of the areas that Leo's discussed today. So if you've got a pipeline, which let's take a pipeline which is currently 25 years old, and you want that pipeline to last another 25 years. So you can do a fitness for service assessment on the pipeline, and you can calculate what wall thickness you require at the end of the new operating life of 50 years. And you can calculate a corrosion rate that is required in order to achieve that new 50-year operating life. So then what you look at is you test in the laboratory a corrosion inhibitor which will achieve the corrosion rates that you need. You then deploy that corrosion inhibitor into the pipeline, and you monitor it using appropriate devices such as internal corrosion monitoring devices, which was referred to by Leo, but also very importantly by inline inspection tools as well, so that you can monitor what is going on. If you find that the corrosion rate is exceeding your KPI to achieve your new 50-year design life, then the first action is to check whether or not you're injecting corrosion inhibitor at the right level, and whether or not you need to increase the dosage. So for each of these, you work within a set of KPIs or integrity operating windows, or call them what you like, but you can apply your boundaries for each of these, and you monitor where you are in the boundaries. If you're getting too high or too low, you can modify your mitigation system to bring you back into the boundary again.
Excellent. Thank you very much. Makes perfect sense. Okay, next question we have is, if residual corrosion inhibitor measurements are not possible, how can we check if the inhibition system is working effectively?
I think my previous commentary addresses that. So monitoring residuals of corrosion inhibitors is very important, and the corrosion inhibitor vendors are very helpful with either providing the methodology for operators to do, or they'll provide that service themselves. And so if you can't do that, then intrusive corrosion monitoring, weight loss coupons, ER probes, provided they are in exactly the right place, because that's an interminable problem. Are you monitoring in the right place? And then doing ILI runs if the line is piggable. If not, then you can do a corrosion modeling assessment along the pipeline to determine the most likely areas for corrosion and do localized bell holes to identify any damage by NDT.
Yeah, thanks for clarifying that, much appreciated. Okay, next question we have here is, you mentioned looking at the material selections in the intro, but I didn't see this in your review. Were the materials actually suitable?
Evening, Steve, long time no see. Last December, I think. So my recollection of this was that all of the materials construction were completely suitable. The organization had done a good job of selecting materials where there had been failures, and they'd done a failure investigation which required upgraded materials. They did that. I think there's a number of important takeaways from the work that we did on this particular case, but also the methodology that was used. I think the biggest takeaway that Leo and I had was that all the frontline corrosion engineers and technicians we met, as Leo said on a few occasions, were very, very good indeed. I was extremely impressed by the quality of the engineers and technicians with whom we interacted. But they were working so hard just to stand still. It was unreasonable. These guys were working extremely long hours. And it was the system in which they worked that was the problem. And from my experience, this is very often the case. I've worked in the North Sea and a number of countries overseas, and by and large, the people I've interacted with have been excellent. Where things have gone wrong, it's the system in which they work, which has not allowed them to work to the full efficiency that they should be allowed to work to. In this particular case, it was because there was lack of clarity as to who was actually supposed to be doing what. So some of the individuals who were so keen on the work were actually taking on far too much work, but they knew that it needed to be done. And they didn't have the software systems in place to allow them to do their work efficiently. So some of these guys were working 7 days a week, 12 hours a day, just to keep up. And that's pretty tough by anyone's standard. So yeah, we definitely came away with the thought that we're dealing with really good people. They just needed a hand.
Yeah, it's often the case in these things, unfortunately.
It is, isn't it?
Yeah. Okay, we've got one more question here from the audience. So I guess it's a simple one to answer. So did you consider using numbers instead of traffic lights in your scoreboard?
Leo?
You're muted, Leo.
Yeah, no, sorry, I was going to say, I'm pretty sure it was Andy who came up with the traffic lights system. I think
I'm dropping you in it.
Now, with regards to whichever system we looked at, the key point we were trying to sort of to get over was because even if you did a 1 to 4, you're basically showing the same thing in that, okay, this is fine, just keep doing what you're doing, or somewhere in the middle, or actually down the bottom you really need to look at improving. So the sort of going to a more specific scoring system, I don't think added that much to it, because if there were problems, they were identified, and if there were severe problems, they were identified. So there was quite a clear-cut definition that allowed us to put it in the green, amber, red. So it's I mean, the other thing that we found is that, you know, when we came to actually present the results and show the senior management, is when they see a big PowerPoint presentation of a block of red, you know, there are very few presentations where that means it's a good thing.
That's exactly right. The issue of traffic lighting, it's very common use across the world, is because it's so easy to absorb a large amount of information in a very, very short period of time. If you put numbers down when dealing with an overview, particularly as Leo says, presenting to management, they need to be able to see very quickly where the holes are, and they will go for the reds, and they will then talk to their colleagues about how to deal with these reds, how to get them down to amber, and then how to get them from amber to green. But they will target the reds. So there are some systems where you can use 1 to 4, and you can do a number of calculations on them if you like. But if you follow this plan, do, check, act system, and you bring in the traffic lighting, it actually works very effectively. So that's why we use the traffic light system. The brain is better at picking up colors than it is at trying to deal with numbers if you're trying to address a large amount of data in one go. And one of the things that, I mean, we haven't particularly highlighted it in this talk, but one of the things that I have an passing interest in, although I have no expertise, is human factors. What allows people to fail? And typically it's not the person, it's the system within which they're working. Most people will do their utmost to be successful and to make sure things are safe. That's certainly been my experience. I worked for the health and safety executive for 9 or 10 years. And that was my experience there. When there were accidents and incidents, it was very, very rarely down to the person. It was the system.
Yeah, absolutely. It's always a system thing. So, okay, is there any more questions from our audience? If you have any, please feel free to type them in now. I'll just quickly ask, is there any questions from the Icor panel that they wish to ask at this moment?
No, thank you.
Okay,
No.
just oh, sorry. There you go, Steve.
Yeah, I just have one on the RACI chart for the corrosion monitoring for the accountable person. Normally, the accountable person also defines the scope of work before the task is actually started by the retrieval team. I don't know if you agree with that, but that's how we normally do it in our company. But yeah.
Yeah, fair point. Agreed.
So if they're the person who's going to get the flack, they're the ones who should have defined what they were going to do in the first place.
Yeah, true.
Yeah, but it's a very good presentation. Thank you.
Thank you.
Yeah,
Okay,
thank you very
just
much.
if there's no other ones, you just have one more for myself. I'll ask one. So, if a North Sea operator wanted to have a similar extensive study done on their assets and their integrity management system, what type of resource would Intersect be able to offer, and what kind of time frame would you be looking to deliver a similar type of scope?
Well, I'll give you 1 year because I'm planning on retiring.
Fair.
We have an integrity group based in Manchester. We've also got extensive facilities in Aberdeen as well. So the director of our integrity group is Joe Morris, and I'm sure he would be delighted to talk to anyone who needs this sort of approach. But in the absence of his email being up on the screen, feel free to contact either myself or Leo. But really the purpose of this presentation, in fact, I've written an article on this piece of work, which Brian Goldie at ICorr Magazine's asked me to write, which will go into a little bit more detail and explanation as to how this system works. But the idea of the presentation and the article I've written is to inform colleagues in the corrosion world that this is another way of doing things. It's another way of doing a review, or dare I say audit. Most people hate the word audit, but you can use this approach that Leo's provided today for pretty well anything. HSG 65 was not written with corrosion management in mind. It was written with a view to how to manage pretty well any organization, any business safely. The beauty of HSG 65 is that you can apply it to almost anything. Flying an airplane, a glider, sailing a boat, technical stuff. It's a system which is extremely flexible and not just limited to corrosion management, but if you want to apply it to, I would suggest instrumentation or process engineering, you can apply it to that as well. And then all we did was link it up with the Energy Institute's guidance on corrosion management to bring it together to make it work. And we've used this system on a few occasions, and it works quite well. I mean, like anything, it's imperfect, but it's a pretty usable system that most people should be able to apply.
Perfect. Thanks for that, Andy. Okay, so the last query we have through is not a technical one, so I'll leave it for Human to answer. But before I do, I just wanted to say thank you, gentlemen, for your presentation today. It was very informative and lots of good information there that you can share and good practice there for people as well that they can pick up on. So thanks again for your contribution.
Thanks for the opportunity.
Just the last one for yourself, Human. So I guess it's clarification on if people want to have access to this presentation with the slides. So I'll leave it with you. Thank you very much, gentlemen.
Thank you, Dr. Oli, for the questions, and thanks a lot, Leo and Andy, for this excellent presentation and the excellent topic as well. So, yeah, regarding this question about sharing the slides, that's fine. As I mentioned in the beginning of the presentation, the slides, the PDF version will be uploaded to the ICorr website, the ICorr Aberdeen website, and the recording of the session, if you have missed a part of that, it will be uploaded by tomorrow on YouTube channel, so you can watch it again. So before I close, just the last point, when you leave the webinar, there will be a survey. Please fill that, especially if you want a CPD certificate. So please specify as yes and put your email address there so we can send you the certificate. And our next presentation will be on 29th of March by Dr. Robert Lindsay from the University of Manchester, and the topic will be corrosion inhibition, separating fact from fiction. Yeah, so I hope to see you all again next month. Thanks again, Leo and Andy, for this excellent presentation, and thank you for your time. Thanks for the audience for staying late with us. Have a good rest of the day or evening.
Thanks all. Bye.
Thank you.
Thank you all.
Thank you.
Thank you.